Hi, howdy. My name is Bill. I'm a landscape designer practicing in China. I got my master's degree in the States in Texas at Texas A&M University. So shout out to Aggies. And I want to make this tutorial to showcase how a landscape architect can create and manipulate the topography. Because engineering and grading the landform, the soil, or the earth is the most critical skill for landscape architecture. And the landform is the foundation of all the form and space, and is the host of all the landscape architecture elements. And before we get started, I just want to recommend this textbook that we use in accredited American landscape programs. It's called Science Engineering for Landscape Architects by Stephen Strom and others. And I think you can also get this workbook as a combo. It has many questions that you can work on to help you better understand how science engineering works. And I especially recommend this book to my coworkers who are not educated in North America. It's very helpful. Alright, without further ado, let's get started. And I don't want to get into every single detail about grading, and you guys can just go read the book I just mentioned. But I do want to go over what's happening here in this project. So we're proposing this large berm in this green area because we want a landmark type of thing. So it's basically a small hill, and we are also putting in some hardscapes like these freeform benches and the patio, and this zigzag footpath that's ramping up all the way to the top and then comes down through these steps. So as you can see, the key element in this drawing is these contours, and you want to separate the contours in two categories, the major ones and the minor ones. And in this case, we just assign two colors to these contours. The darker ones are at the contour interval of 1 meter, and the minor ones are at 0.25 meter. And then make sure you label all the critical elevation point with the respective abbreviations. And for the contours, I just want to bring up two major points that's important. The first one is contour breaks. For the most part, contours don't break because they are imaginary continuous lines people created. So they don't exist physically, but they do break when they hit structures with a certain height and elevation, and that's where they will break if you draw them in plan. And the second point is that contours don't overlay, but there are still some exceptions if you have a very tall structure like retaining walls or very deep dent, but in those cases the soils are retained too, so the contours can actually overlay along the retaining structure. But in this case, our modeling method just don't go along with the overlay contours. So the process is you first draw the outline or shape of this berm um, that you desire. Then you can just pretty much offset the outline uh, to meet the contour intervals. Then you can do the adjustment as shown in these green lines according to the structural elements you're gonna put in. For example, these benches, patio, and the ramp. Um, these will result in the change of the shape of these contours. So after you finish drawing the contours, you want to clean up the CAD file. Just make your proposed contours tidy, and then you want to separate them from the belt elements. So you have to get the two files ready. Alright, now we got the CAD files ready for use. We're just gonna import them in the modeling software Rhino, and we want to use its powerful plugin Grasshopper to achieve more accuracy and efficiency. And Grasshopper is the so-called graphic interface programming. I think it can help designers without a coding background to upgrade their design with the help of and the power of writing computer scripts. And again, I'm not gonna get into the details of Grasshopper, but I will go through what's listed here. We're gonna do the model via connecting these boxes, which are called Grasshopper components or nodes, and we actually call them batteries in Chinese according to their graphics. So first we'll use the curve component to pick up all the curves in Rhino, and then we want to use join curve component to join them. We want to make all the curves perfectly closed, and then we want to use the sort list component to sort the curves by their length. Then we can move all the contours vertically in the arithmetic progression using the series component. And note that I'll leave out these platform areas first because we want to put them back in with all the other contours after we move out the contours in the right order at the right elevation. So after we put all the contours at their correct elevations, we can use insert list to make the complete list of contours. And after we're done with sorting these contours, we can then go ahead and break all these contours into points, again by their length. Then we'll send these points to the component called the Lao name mesh, and then we'll make a mesh out of our landform. Then we can go ahead and bake the component into Rhino, and just remember to set up your layers with the correct naming. And then we're gonna do the next step in Rhino. And because mesh in Rhino is relatively difficult for further adjustment and manipulation, so we need to transform this mesh into a surface. And we'll do this by typing the option drape, and It's basically the simulation of gravity, so it's very good for making landforms. And note that we can adjust the accuracy of fitting um, by choosing the spacing number. Alright, now we got our surface done. Then we can go ahead to making the ramping footpath and the stairs. So again, we'll break the footpath into points first, and then we'll project these points down to the landform surface. And after we project the points, we can use the component interpolate to reconnect all these points. So now that we have the curves and the points, we can use the component patch to generate the surface of the footpath. And this component can also smooth out the footpath surface at the same time. And because our landform surface is based on a mesh, and mesh is formed by a lot of triangular faces. So if we just project the footpath onto the landform surface, it will be very bumpy. So using this component will help us achieve the best result. And you can adjust the parameters of spans and flexibility to minimize the difference. Alright, now we can move on to the stairs. But since stairs is not the focus of this video, so I'm just gonna skip through the actual process. But I just made a formula-like group of components to help me get the stairs done. So again, we can bake the stairs into Rhino first, and then we'll adjust the footpath manually to meet the elevation of the staircases. And you can just select the footpath surface and then press F10 to open up the control points of the surface, and then do the manipulation. And you can also use the option set point to better align the control points with the stairs. And then don't forget to offset a surface by a certain thickness to represent the pavement. And then also adjust the landform surface accordingly. So our final step is to set up the taller structures. I'm gonna use this bench as an example. You want to first cut an opening on the surface, and then just put the bench back to its place, like that. Alright, I hope you guys find this video helpful, and don't forget to leave likes and comments down below in the comment section.